Hello everyone, this is Bradley. Today this is a tutorial for this disintegration depth effect. I was replicating an effect I saw from a game, which I think very interesting. So here this is the tutorial of that. This tutorial should be quite straightforward, but during the problem solving process, there are certain issues which I find a little bit tricky. So we are going to discuss that and hope you can learn something. So let's start. So here we are in Blender. At first, let's discuss the basic concept of this entire animation. How can we approach this issue? This tutorial will be split into two completely unrelated parts. At the first part, we are going to solve the alpha transition in material. And then in the second part, we are going to talk about how to emit particles. This means that the material alpha transition has nothing to do with our particle emission. In the past, when I talked about a similar kind of animations, for example, the burning effect and so on, I combined these two effects into a single one. They are related to each other. But in this tutorial, I will completely separate these two processes. So this is it. As we are clear with the basic concept, let's move on to demonstrate each individual part. And as always, I may use presets which you can download for free from the link in the description. I will try to minimize that simply because this effect should be rather easy. But anyway, so this alpha transition effect is rather straightforward. We have a noise texture and I have a mask node, just plus minus it to have a transition from black and white. And as I run this factor from 0 to 1, from black to white, I have a transition of this color. And I output this color to this emissive alpha BSDF. This preset is pretty simple, but I use this function so frequently for this kind of emissive alpha effect. It's basically just a combination of this mixed shader between the transparent BSDF and the emissive BSDF. And you can see these sockets are even corresponding to each other. And I have a factor for this alpha. And here we need this alpha to work. I just copy this color ramp and an alpha matte should basically just be black and white. So I remove this red part. The black part will be invisible. The white part will be visible. Okay, so you need to play around with this color wheel, or you just copy paste that, whichever you want. Okay. And in this case, you can even reverse the order of it so that you have a white center and a red edge. Up to this moment, everything is kind of very straightforward, and we can apply this concept to a greater context with our armature in this case. However, I was a little bit shocked when I looked at our armature. This is an armature, the character and the rig downloaded from Mixamo. And it surprises me because there are kinds of problems I didn't realize at the beginning. I have multiple body parts of a character. This makes sense because a character can have its own head, skirt, shoes, gloves, into different parts, but I forgot. And the second issue is that this character, even for a single part, it contains multiple materials. This means that it would be better if you work after the initial principle BSDF and you find ways to combine these different parts together. So what I mean is that, for example, you have a mix node, the mixed shader node. And after you're done with this entire node graph, you put that into a group node so that you can just copy paste this group node into different parts and connect them together. So it will solve the problem. So this was my plan. And once we decided this plan, we can do basically the same concept with our node graph using the previous setup. So here I'm just going to copy paste this entire graph to our material. And I'm going to start to mix the transparency and others with it. As we need to mix with the original principal BSDF, in this case, I need to separate this emissive alpha into its original form, but I'm going to basically keep this mixed shader and the transparent BSDF. So I mix these two together, and I use this alpha into the factor. So now I will have a transition effect of this character, but I do not have my emission. So for the emission, I'm just going to use an add shader instead of the mix shader and plug in that in. I only need the red edges. So for the center part, I can just take that into black. And you can try to tweak the thickness of this edge. You can use an emission shader, and you can increase the strength to cover the original shader. You can grow it. Just remember to turn on the viewport compositor to always or camera. And in the composite, you need a balloon glare node, and attach that with the composite so that your character will glow even in the darkness. Whatever. So now you can animate this mass function just to animate the appearing and the disappearing of this material. And what we can do is just to put this entire thing into a group node. And you can call that as a alpha transition. And then we just copy paste into other parts so that different materials will share the same parameter that's used inside this node group. If I'm using a simple add function, then this entire character has been deleted. Okay. Which is kind of very simple. And now if you set the value to the middle part of our transition, and if you play this animation, you will find that this texture is glitching on our character during the animation. This is because of the coordinates. If you look at the coordinate by default, it's using the texture coordinate generated. The generated is forming a bounding box of your character. And it seems like it's moving because of our armature deformation, because as the entire mesh fold, the bounding box changes to another form. However, this is actually a bug in Blender. You can fix that if you just hit this current frame, and you will find it will stick to the character. This is really a bug. So no matter if you do this kind of a click, once you render, it will not really glitch. Okay, I'm not sure when the bug will be fixed, but this is the situation. On the other hand, you can also use the UV, but the downside of using UV is that if you look at this UV, you will find that there are seams, and sometimes these seams are not very appealing. When you have the noise texture transition, it feels like two parts are not very connected. Like this part have a half circle, and then the other part is intact and have another patch disappearing. So it feels kind of very weird. So the recommendation is just not to use it. you better just stick with the generated. So now we basically have finished the shader part of this entire animation, and we just need to animate that. Since this is inside the group node, this means this value is shared for all this kind of texture using this group node. Just for convenience, I'm just going to keyframe it by hitting and right click and take insert a keyframe. And you have to select the node in order to visualize this keyframe. And then you just put a negative 0.3, something like that. I'm just eyeballing the effect and insert another keyframe. Then you have this disappearing animation, but without the particles. And then we are going to deal with the particle system here. I'm going to use geometry nodes to emit particles. So let's go to the node editor. I need a plane to hold this geometry node modifier. I'm going to use the simulation zone method to emit particles because our armature is essentially moving. So I want to have a more dynamic kind of effect for our particles. And since this is particles in geometry nodes, I'm going to use join particles preset. Again, you can download these presets for free from the link in the description. Essentially, it's just a join geometry nodes, but it includes some additional functions such as storing different attributes for velocity, ID, and the birth state of our particles, which can be very useful. And in this case, I just drive this armature collection inside, and you can take a point distribute to set up the particles, and you will find that it's very slow, like half of a second. This is because the geometry node does not read the armature very well. So it would be better if you just realize the instance so that only geometries are being accessed for geometry nodes, and then the time slows down. The time decreases. Next, we can set this normal to velocity, and we need a set position to drive these particles with this velocity. And now if you play this animation, you will see there is a kind of pattern of this particle emission. This is because every frame we're using the same seed to spawn these particles. So the emission origin becomes quite consistent. And here we can just use a seed per frame so that we change the seed every frame, and we have a kind of irregular location to emit these particles. And once we go into the simulation, you can see you no longer see the patterns. Okay, it becomes very chaotic, which is what I want. And the next thing I would like to do is that I want to have a force to drive these particles afterwards, just like a gravity, but in an opposite direction. So I'm going to take a cumulative force. I probably talked about this preset in the past, but essentially it's just a store named attribute, and we add a new vector to this named attribute every frame. In this case, we just make them consistent as velocity, so that every frame there is a new force or new velocity being added to the original velocity. So while these particles always emitted along this normal, but there is another upward force being added. This means that if you play this animation, then these particles will, just like a gravity, they are always going up, and this force will become larger and larger as you go. Here I should change this vector into the offsets. There is no real difference whichever one you use, because the attributes inside are basically the same. They're both the velocity v I'm using from these two inputs. Okay. But if you're having a different attribute, then it will cause difference. Okay. In this case, they are the same, but anyway. And the next, we can basically just make these particles into a real geometry using instance on points. And it might sound a little bit crazy, but I'm going to use the grid so that to hold a texture. Let's store name the attributes. No, actually I need to store the UV map. And let's set a material. I need a particle material. And I also need a random rotation for my grid particles. And we need to change this scale. So take a value position, randomness, to add a kind of random value with it. We also need to make these particles scale 0 at the beginning of their lifetime, and then they grow back bigger. And in this case, we can use a time fold. This birth state is stored within this join geometry. And from this birth state, we are calculating this time fold from 0 to 1. And you plug that into the value position. So you can see we do not have particles at the beginning, and it scales up bigger and bigger. And this duration will be their lifetime. We can remap this fold from 0 to 1 to 0. So once you reach this lifetime or duration of 25 frames, then these particles will basically scaled to none. And you can increase their lifetime by 80. Then you have these particles. Okay. Basically, this is animation I'm looking for. Right now, I realize I'm having a little bit too many particles generated for this animation. So there are several ways to deal with that. One kind of way is just to decrease the amount of particles you spawn on our character. If you decrease that, you can see there is a decrease of our particles. Another way is to increase this join interval. It will mean that every 4 frames we're joining these particles. Because the frequency to emit particles becomes lower, so you will have an overall decreased amount of particles generated. So these are basically 2 ways that you can manage. Of course, there are many other ways as well, but that's kind of too complicated or whatever. And in this case, I do not want to emit particles at the beginning. It should be related to our animation. So in this case, what we can do is to just keyframe that. Yes, I'm just going to keyframe that. So I'm going to set the emit amount as 0 so that there's no particles being actually spawned or emitted. But then over at a certain point, like this 40 frames, I'm going to emit that. Insert a keyframe, and I'm going to decrease this linear relationship just by hitting T. I'm having a constant interpolation so that it will basically go from 0 and jump to 4 immediately. Okay, and I'm going to set another keyframe to make it dead. 0. Okay, this is not a very procedural. Of course, you can make it a procedural, but I'm not going to do that in this case. So basically, this is the animation. And if it goes to the material preview, you can preview this animation better. But we also need to deal with the shader of these particles. Instead of having grid, I'm going to make that a kind of a spherical particles in this case. Next, let's go to our shader editor. And let's enable our UV map using the attribute node. Visualize the UV. Let's play this animation and we can see this character disappearing, and we have these particles being emitted. The UV map of our particles on a grid is basically going from 0, 0 from one corner to 1, 1 on the other side. And this is causing that if you put a gradient texture, the spherical center is always on one corner. So we need to offset that. So using a center UV, which is really just a subtraction of 0.5 on 3 axes. And now if you try to multiply that, no, actually you can try a vector mass scale. And then you can scale this sphere down by increasing this coordinate. And we need a emissive alpha BSDF to deal with the alpha. And we need to remove this noisy by changing the render mode to blend it. Let's take a color ramp so that we can change the color of this sphere. I'm going to add a red. The center should be red. And the edge should be black. It may not be very obvious right now because we also need to deal with the alpha. So just give you kind of a short demo, you can just increase the emission. Then you can see we have a red edge and a black center. We can make this alpha more prominent by using a sharper color ramp to change this white handle. And in this case, we need to see the glow of it or the bloom of it. So let's enable this compositor and remember to turn on this use node, glare bloom node into your render layer. So now we have these kind of circles being generated. And basically this is it. We can add a noise to the coordinates of this spherical gradient. So let's take a noise displacement. You can also use a vector noise. Basically, they are very similar in this case. So let's just noise displace that, and it will take a little bit of time to compile. In this case, you can see this is kind of very noisy. You can decrease the frequency, maybe like a 1.5, and increase the scale, something like that. Right now, you will realize that because these are instances, so they're the same, just being oriented differently because we are using a random rotation. You can also change the seed, but anyway. So in order to change this texture for differences, you can use a realized instance. And previously, we already stored an ID in these drawing particles. If you directly use this ID is a very big number. So I'm not sure if it will work. But if you plug that in, then it will have a kind of very noisy whatever stuff. This is also a kind of known issue in Blender that you should not input a kind of integer value from geometry nodes to shader. So we are going to store a new named attribute. Let's take a named attribute ID. And we're going to put that into a white noise. And you can name that whatever. Let's name that as a W. And we're using this W. And then you should see the kind of differences of texture being generated. Maybe it's kind of very small, so you can try to scale it up. I'm not sure if it's very obvious about the different shape of them, but probably it's not very important. But basically this is it actually. So you have a character disappearing, and you're emitting particles with it, with the amount you set, with the join interval you set. And basically this is it. And you no longer have particle emissions after a certain time you set. So this is basically it. Technically speaking, this kind of effect can be combined with a shader so it becomes 100% procedural. That's where you eliminate will be where you emit particles, like the burning tutorials I made in the past. The reason I didn't connect these two parts, or I separated these two parts, is because I do not want to subdivide this geometry. After all, geometry nodes requires all these kind of polygons. So this is the reason I separate these two concepts. But anyway, so I hope you enjoyed this video. I'll probably see you next time. Bye bye.